look into second example of this electrical system. We have two resistors, one capacitor and one inductor. So we have to label the voltage across each element. So we have VR1, this is VC, voltage across capacitor, voltage across resistor 2 VR2, and voltage across inductor VL. Now input is Vi and output is V0. Alright, so in this case, if you notice, V0 also equal to VR2. Okay. So notice also we have a junction here. So when we have a junction, we have to apply Kirchhoff law for current. Current goes in equal to current that coming out. So let's say this is I, coming out is I1 and I2. Again, this is I. Okay. Now we start to derive the equation for this electrical system. We start with the summation of summation of voltage in the loop. So we have Vi minus VR1 minus VR2 minus VL equal to 0. So we have here, notice we have branches in parallel, so that's why I just put it VR1, alright, because voltage across parallel branches are the same. In this case, if you want to label another voltage in general, voltage across this element, let's say Vn. So voltage across this component Vn equal to VR1 or Vc. Okay, so they are the same. And then Kirchhoff law for current, we have one junction here, so we have I equal to I1 plus I2. Let's say this number 2. So the individual equation we may write VR1 equal to I1 R1. Say this number 3. VR2 equal to I R2 number 4. VL, okay, VL LDI number 5. And for capacitor we have I that pass through the capacitor is I2 equal to CD VC, is number 6. Right, we have the equations needed to form the block diagram. Okay, we may start with summing point. The output is Vi, so Vi should be on the far left of the diagram. Okay, we start to use equation number 1. Yeah, so Vi minus VR2. Okay, VR2. I can put VR1, not a problem, because this is algebra. So this is VR1, okay, or Vn. So Vi minus VR2 minus VL. Sorry, this is should be minus VL. Alright, so minus VL, VR1, VR2, and minus VL. So we have here the output is VR1. Okay, VR1 or Vn. Okay. So that is from equation number 1. Then from VR1 we can derive I1. Okay, we want to derive I1 here, so we can use current for next equations. So VR1 here, or Vn or Vc, they are the same. So I want to derive I1 here. So you have VR1. So you have to divide the signal with 1R1. The output is I1. Okay. Now we have to have the output on the far right, which is V0 or VR2. So VR2, equation number 4. If you can derive I, or you can find where I in the system, then you multiply with R2. Now from current equation, Kirchhoff law for current at junction. So I1, how to get I from I1? So I1, you have to add, okay, I2, the output is I. So then equation number 4 can have us I multiply with R2. So we have here VR2 or V0. Okay. So that is the fourth path. Next is to connect or find the sources for all these variables. So VR2 already at the end here, so you can connect VR2, this VR2 from here. So this is VR2. VL still not used, the equation is number 5. Alright. VL LDI. So you find I and then you multiply with LD. So this is I multiply with the signal, multiply with LD, the output should be VL. VL should be for this signal. So we have to mark this already used, this one already used, 3 also already used. Now I2, how we can find the source for I2? The equation that's still not being used is number 6, I2. I2, if you can find VC, then you multiply with CD. No VC here, but we already discussed just now, VC equal to VR1 or Vn. This is also equal to VC. Okay, VC. So VC, you by using equation number 6, VC you multiply with CD, the output should be I2. So this for this one. Alright, that is the block diagram for this system.